What is time? Now, it may surprise you to learn that I won't actually be answering this question during this video, but I probably will be asking a lot more questions. Time is a very peculiar thing, or perhaps I should say that our perception of time is a peculiar thing. Or is it, in fact, actually a perception of time at all? What do we actually perceive? Well, we perceive change. Or no, rather, we perceive difference. The difference between two states. We see state A and we see state B. And we conclude that state A has changed into state B. But has it? Maybe we've moved in space. Maybe what we perceive as state B is actually slightly different from state A, but not its temporal successor. It's just over there somewhere and we've shifted to that position. State A is still over there somewhere, unchanged. But we're still kind of using temporal language here. Even if we have moved in space, we still have a sense that now we are here, but before we were there. Perhaps this is the first interesting thing to note about what we call time. Perhaps it's not actually so very different from space. We assume when we see change that the thing we now perceive, state B, has replaced state A. But if we have moved, maybe that's not true. If we see state A here, then move 100 meters to our right and see state B, which is very like state A but slightly different so that we can actually tell the difference, we don't assume that state A, 100 meters to our left, has ceased to exist. Could that be true of time as well? Initially, when we talk about moving through time or going forward through time, we may be using this as a kind of analogy based on what we actually do in space. But maybe it isn't an analogy. Maybe time is actually much more like space than we initially think. When you think about it, this is not so far-fetched. After all, Einstein showed that there is no such thing as time and space, but rather this one thing called space-time, with 3 dimensions of space and 1 dimension of time. Maybe what we call time is, in fact, another dimension of what we usually call space. Or perhaps it's better just to say that all 4 dimensions are dimensions of this one thing called space-time, which is really what the general theory of relativity states. There do seem to be some peculiarities about this 4th dimension, though, compared with the other 3 dimensions. The main one is, of course, the direction in which we can, apparently, move. If we consider up and down, left to right, and in and out of the page, we can easily move in 2 directions along any of these lines. However, when it comes to the timeline, we seem to be able to move only in one direction, what we perceive as forward toward the future. We have no trouble envisaging a time that goes in both directions, but we don't seem to be able to move in the other direction. We don't seem to be able to move backwards. How do we know, though, that we're moving forward? Note that here, forward is really an arbitrary term. Let's say instead that we can move in a positive direction, analogous with that on the other dimensional lines. It would be like only being able to move to the right or only go up. We know that left and down exist, but we can't go there. That's what time feels like. The reason we perceive ourselves as moving only in this one direction in time, in a positive direction, is what we call the arrow of time. This usually refers to entropy. We perceive an increase in entropy, i.e., roughly speaking, a decrease in order. The kind of example given to illustrate this is that of an egg rolling off the table and smashing on the floor. If we see a video of this shown in reverse, i.e. the egg putting itself back together and jumping back up onto the table, we know that that video is being shown in reverse. But this is not the only thing that reveals to us the direction of time. it's of the only arrow. An observed decrease in entropy or increase in order also reveals to us the arrow or directionality of time. Suppose, for instance, that you watch a time-lapse video of a plant growing. As the plant grows, the entropy decreases and the degree of order increases. If you play the video in reverse and you see the plant shrinking, you know it's in reverse, that time is running backwards in that video. So our sense of the arrow or directionality of time is not dependent solely on the perceived increase in entropy. Whether what we observe is a decrease or an increase in entropy, we're still able to perceive this directionality in time. And we, so far as we know, can only travel in the positive direction along this axis. We can perceive this with no apparent change in entropy of the system at all, in fact. For instance, consider a metronome clicking away over there. As far as we can observe, there is no change in entropy in that system over time. Of course, if we could perceive this more closely, we would be able to tell that the arc of the metronome would be slowly decreasing in amplitude. There's an increase in entropy. But the sound it makes wouldn't change in rate because the duration of the period would stay the same. So we listen to our metronome. We hear click, 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 and we know that those clicks are occurring in a particular order, that click 3 follows click 2, which follows click 1. At least, we think we know that. We think we know that, even though if it was reversed, we wouldn't notice any difference at all. It would sound exactly the same. There's no perceptible change in the rate of the clicks. Click 1, 2, 3 sound exactly the same. Yet still we think that click 1 is followed by click 2, which is followed by click 3, and so on. Why do we think this? If we were watching a video of this, we wouldn't be able to tell which way time was moving. But when we're observing it in real time, so to speak, we seem to think that we can tell. Again, why is this? Because, I think, what we perceive to move through time is us, ourselves, our awareness. I am moving through time, or so I perceive. Therefore, click 2 must follow click 1. Just as we might observe state A and B in space, if we move over to the right, and we know that state B is here and state A is there, somewhere along the axis, so too we know that click 2 is here on our timeline and click 1 is over there, further back on the same timeline. The difference is, of course, that we can't go back along the time axis to see if click 1 is still there, the way we can go back along the left-right axis to see if state A is still there. Of course, the word still already demonstrates the dilemma to some extent because it has temporal connotations. We can't escape it in our language. Another odd thing about time, or perhaps it's actually an odd thing about space, is that movement through space requires time, although movement through time does not require space. We can't move from A to B without also passing through time, at least so far as we know. Instantaneous spatial displacement doesn't seem possible, even in principle. For it to be truly instantaneous, we would have to be in two places at one time. Otherwise, there is a before and after. But we can perceive the passage of time without any spatial movement at all. Even in a completely empty space, we still have an internal perception of the passage of time. Perhaps we might argue that this is because even internally there are things moving around in space. Movements in our thoughts reflect actual movements of molecules, electrons, other quantum particles through space. I'll concede that that is possible. However, we certainly perceive the movements of our own thoughts as having a temporal direction, even when no motion is perceptible to us. But we can't move through space without also having a sense of moving through time. It would seem, therefore, that spatial movement is dependent on time in a way that temporal movement is not dependent on space. So, Is temporal motion a prerequisite for spatial motion? Is time itself, in fact, a prerequisite for space? Now, I don't think this necessarily follows as a strict logical consequence of this line of reasoning, but I toss it out there for consideration that perhaps time is a prerequisite for space. Before finishing up with this admittedly bewildering concept of time, I want to ask one more question, or at least I want to challenge one of the assumptions I've been making, namely the assumption that we can in fact only move in the positive direction along the time axis. What about memory? Is that a kind of movement in the negative direction along the time axis? Probably not our ordinary memory. We know that what we're doing is remembering. We know we're not actually there. What about under hypnosis, though, when we're taken back to an earlier point in our experience? Now, I've never had this experience, so I don't know how realistic it feels, if it feels as if you're really re-experiencing these events. Let me know if you've had this experience and what it was like for you. But even if it really is a kind of going back, it's still not like moving through space. When we move through space from A to B, we have a sense of passing through each point in between. But when we move back to this earlier point in our timeline, we just pop right back to that point without any sense of traversing every point in between. The same would be true if we were somehow able to shift our own consciousness back to an earlier point in our own timeline. Note, though, that if we actually succeeded in doing that, we wouldn't know that we'd done it. If we're consciously aware of what we've done, we're not actually back at that point in our timeline because our consciousness, our awareness, is different from what it was then. Our present self is experiencing this. It's a new point in the positive direction of our timeline. In our experience, we know that this experience of going back to an earlier point in our timeline comes after the point before we undertook this movement. If we don't know this, it's not clear that going back has any meaning at all. Also, when I'm back there, having made this transition without passing through intermediate points along the timeline, whether this is a real movement or just an hypnosis-induced memory, we continue to experience time as moving only in the positive direction. Even if we make that jump, we don't live backwards. Now, this says nothing about the concept of time travel as science fiction usually depicts it. Not just a movement to an earlier point along my personal timeline, but to a time and place that I may never have occupied before. But even if this were possible, we would still inexorably experience the movement of time only in the positive direction. At my present moment, I'm in the Cretaceous period, trying not to tread on butterflies, while a moment before, I was in 2024. Well, I hope that sorts out the whole time thing for you.